doing notes on stoichiometry today. You should have already done the notes on mole conversions and practiced those so that you're ready to add on to that. So stoichiometry is basically the same thing, except now we're going to bring back in our balanced chemical equation. And you might have to do some writing of formulas to get that balanced chemical equation. So stoichiometry is a fancy way of saying we're going to figure out the quantitative relationship between two or more substances in a chemical reaction. Remember quantitative? What do you think? We did quantitative and qualitative at the beginning of the year. Remember qualitative? It's like a physical description, or like what color it is, or how hot it is, how hot it feels. Or quantitative is a quantity, like exactly what temperature is it when you measure it, or what's the mass of it. So here it's the quantitative, the numerical relationship between two or more substances in a reaction. The first thing you have to do when you start is come up with a balanced chemical equation. Sometimes we'll give you one, and then sometimes we make you come up with it on your own. Your test will have a little bit of both. We'll start off with some easy ones, and then you'll have a big problem at the end of it where you have to come up with your own equation and balance it, and then do the math too. So just to review a little bit, here's an equation that I came up with. We've got magnesium reacts with oxygen to make magnesium oxide, and I balanced it by putting those coefficients out in front. So now in this equation, we have two atoms of magnesium, right? Because magnesium is an atom here. And it reacts with one molecule of oxygen. Reviewing a little bit of what molecule and atom means. Molecule, it's O2, is one of your diatomic molecules. There's an understood one out in front. And then you've got two molecules of magnesium oxide here at the end. That's your ratio. Now we're going to represent, those coefficients for us are going to represent moles. So here we've got 2 moles of magnesium for every 1 mole of oxygen for every 2 moles of magnesium oxide. You're going to have to pause this so you can write down the notes, because I'm going to talk through it pretty fast to try to meet my 15-minute time limit here. The coefficients are going to tell us the ratios of reactants and products. So like I just said, you could also write it like this. You've got 2 moles of Mg for every 1 mole of O2, and you always get 2 moles of MgO. You have to have that ratio, a 2:1 to 2 ratio. This is going to be called our mole ratio. This is our only other new conversion factor. So now we've got the molar mass conversion factor, grams to moles. We've got the 6.02 times 10 to the third particles for 1 mole. And now we've got mole to mole. In that last tutorial, I told you that the mole, it would always be 1. Now here it's not. In the mole ratio step, the number for the mole is going to be whatever it is in the equation. So here it's a 2. Here it's a 1. Here it's a 2. You're getting those numbers from your balanced chemical equation. It's a conversion factor, so you could write it 2 moles of Mg, 1 mole of O2, or you could flip it and have 1 mole of O2 on top and 2 moles of Mg on the bottom. Or here I've got it with the MgO and the oxygen. This mole ratio step lets us convert from one substance to another. So if they give you an amount of reactants and they want to know how much product you get, you have to go through your mole ratio step to get there. I'll show you a map and after you try some of these problems to show you how that works. But let's jump right in. Let's do a simple one, a mole to mole stoichiometry calculation. I'm going to use the same chemical equation. And we have 3 moles of magnesium, and they want to know how many moles of magnesium oxide will you make. Sometimes to help you visualize it, it might help you to write out what you got on your equation. So I'm going to write 3 moles here, and we don't know, X moles there. We can ignore the oxygen. They're not asking for oxygen. They're not giving us oxygen. So in this simple problem, we're just going to ignore it. We're going to assume that there's enough oxygen in the air that we don't run out of oxygen. Just like all your other dimensional analysis problems, you're going to start out with your given over 1. You have to put the label. You have to put the mg because we're going to end up going from mg to mgo. So I need to know where it's mg and where it's mgo. Whoops. There we go. Put it over 1. All right, and just like any other dimensional analysis problem, the first thing you should do is just make sure in that second step that you're taking the unit that's on top. And you can pretty much just copy and paste it down here. It's always the same label, so I don't want it underlined. So this is our new step. This is our mole ratio step right here. You can label it in your notes. This is where we're pulling those numbers from the balanced chemical equation. So for every 2 moles of Mg, we make 2 moles of MgO. 2-to-2 ratio. You don't have to simplify. You can just use the numbers that they give you. You get the same answer either way. And I did it times, but that's it because we are at what they're asking for. They're asking for how many moles of magnesium oxide you'll make, and we've got moles of magnesium oxide on top. So that's it. Mole to mole stoichiometry calculations are just these 2 steps, or you're given and then one other step. Your 2's cancel. So you really shouldn't have to plug it into your calculator. You end up with 3 moles of MgO. Notice I've got this label on every single step. I've got the mole, which you're used to putting, but then you have to put the formula label too. All right, next problem, we've got mass to mass calculation. So now we're going to bring back our molar mass conversion. You're going to need to pull up a periodic table so you can calculate your masses. Here we've got silver nitrate reacts with sodium chloride in a double displacement or replacement reaction, and they want to know, I like to highlight what they give us and what we need to figure out. They want to know how many grams of AgCl. So I'm going to go ahead and write that on top of my formula here, my equation. This is the one we're trying to find. And they're telling us we have 17 grams of silver nitrate. That's this one. Oops. So we're going to start with our 17 grams over 1, and I got to have the AgNO3 on here. Okay, so now on the bottom, I'm not in moles, I'm in grams. So I need to copy and paste this label down here. How do you find grams? You're going to find grams the same way you've been finding grams. You're going to have to look at your periodic table and add up your masses. So you're going to write that off to the side somewhere. You look up silver. Silver is 108, so we're going to have 108 plus. Nitrogen is 14. We've got 3 oxygen, so 3 oxygen is 16. plug that in your calculator. And I already did that. I got 170. And that's your molar mass. That's your mass for 1 mole. All right, so that gets us to moles, but remember, we are still pretty far away from what they're asking for. We're trying to get over here to AgCl. But since we're at moles, now we can go to that mole ratio step. I'm going to put moles of AgNO3 on the bottom of my next step. Remember, that's the easiest thing to do first. You don't have to think about it. You can just copy and paste your unit down there before you try to figure out what exactly you're doing. So I have to have moles down there. And this is where I'm going to look at my reaction. You can see it's already balanced. Yes, there are just ones in front, but it is balanced. So I only have 1 mole. My ratio is 1 to 1. I've got 1 mole of AgNO3 for every 1 mole of AgCl. So I also have 1 mole on top. We're getting close, except now we're at moles of AgCl, but they want to know how many grams. So you've got one more step. You got to get to grams. We were in grams at the beginning, but we were in grams of the reactant, and now we're trying to figure out grams of this product. So again, copy and paste before you overthink it. Copy and paste your label down here. I'm running out of room. All right, there we go. I'm going to do the molar mass on this step. I'm going to have 1 mole of AgCl, and I have to find the mass of it. Remember, anytime they ask you to find mass, you're going to look on your periodic table and add up your masses. This was the mass of this one back over here. But silver, remember back from this one, silver was 108. So we're going to do 108 plus chlorine is 35. That's 143 grams AgC. Oh, all right. So all your mass to mass conversions are going to be these 4 steps. Start off with your given over 1, change your starting mass to moles, do your mole ratio step, and then convert to the grams of whatever they're asking for. When you plug that in your calculator, remember you multiply if it's on top, divide if it's on the bottom. So I do 17 divided by 170. I can skip this step because it just cancels out, and then times 143. So I already plugged it into my calculator. I got 1.43 times 10 to the first grams AgCl. You got to put your whole label on there.